Alright, let's go. Number 12. The sum of all numbers. The equation that says 1 plus 2 plus 3, continued forever, equals negative 1/12. And physicists keep finding it in the real world. In 1913, a self-taught Indian mathematician named Srinivasa Ramanujan wrote a letter to the British mathematician G.H. Hardy. The letter contained a series of equations, and one of them looked like a joke, or a mistake, or the work of a madman. Ramanujan claimed that if you add all the natural numbers, 1 plus 2 plus 3 plus 4, continuing to infinity, the sum does not diverge to infinity. It converges to negative 1/12, a positive infinity of positive numbers, adding up to a small negative fraction. Hardy later wrote that the letter was the single most extraordinary document he had ever received. The result, when analyzed through a branch of mathematics called analytic continuation, turns out to be correct. Not approximately correct, rigorously, provably correct, under the formal rules that govern infinite series. The sum of all natural numbers, in a precise mathematical sense, is negative 1/12, but the anomaly is not in the mathematics. The anomaly is in the physics, because this absurd result, this equation that looks like nonsense, keeps appearing in real experiments. In 1948, two physicists, Hendrik Casimir and Dirk Polder, predicted that two uncharged metal plates placed extremely close together in a vacuum would attract each other due to quantum fluctuations. The calculation that predicts the force depends directly on Ramanujan's sum. Negative 1/12 appears in the formula, exactly as Ramanujan wrote it. The Casimir effect was measured in the laboratory in 1997. The force is real. It matches the prediction, which means that the sum of all positive numbers equaling a negative fraction is not just a mathematical curiosity. It is a statement about the physical universe that has been experimentally verified, and no physicist can explain why. The mathematics works. The experiments confirm it. But the question of why the universe behaves as if 1 plus 2 plus 3 equals negative 1/12, what that could possibly mean, what kind of reality would be built on a rule like that, has never been answered. The equation sits in physics textbooks like a loaded weapon, used daily, understood by no one. Number 11. The digits of pi. The number that contains every phone number, every name, and every secret ever written, and we cannot prove it. Pi is the ratio of a circle's circumference to its diameter. It is roughly 3.14159, and then it keeps going. Forever, without repeating, without pattern. As far as we have computed, and we have computed over 100 trillion digits, the decimal expansion of pi shows no structure, no cycle, no detectable order of any kind. Mathematicians have a term for what pi appears to be. It is called a normal number, a number in which every possible sequence of digits appears with equal frequency. If pi is normal, then somewhere in its expansion, your phone number appears. Your name, converted into numbers, appears. Every book ever written, encoded as digits, appears an infinite number of times. The complete works of Shakespeare are in pi. So is a version of the complete works of Shakespeare, with every word misspelled. So is the exact date and time of every event that will ever happen. Here is the anomaly. We have computed 100 trillion digits of pi and analyzed their statistical distribution with the most powerful computers ever built. Every test we have run is consistent with pi being normal, and we cannot prove it. After 2,500 years of studying this number, humanity's best mathematicians cannot prove the most basic fact about its digits, that they are random. The disturbing part is what this implies. Pi is not a human invention. It is the same in every universe, every galaxy, every possible reality where circles exist. It is, as far as we can tell, a fundamental constant of mathematics itself, and if we cannot determine whether the digits of pi are truly random, then there is a simple, definable, absolutely fundamental fact about the mathematical structure of reality that is permanently beyond our current methods of proof. The number that defines every circle is hiding a truth that the entire apparatus of human mathematics cannot reach. Number 10. The monster group. The largest finite symmetry in mathematics, which has more elements than there are atoms in a trillion Earths, and somehow describes the universe. In the 1970s, mathematicians completed one of the largest projects in the history of the field, the classification of all finite simple groups. These are the fundamental building blocks of symmetry, the mathematical atoms from which all symmetric structures are built. The full list contains 18 infinite families and 26 exceptions. And the largest exception is something called the monster group. The monster group contains approximately 8 times 10 to the 53rd elements. It describes a symmetry that exists in 196,883 dimensions. It is so large that it cannot be written down, cannot be fully computed, and was only proven to exist through a chain of reasoning that stretches across hundreds of papers by dozens of mathematicians. Then, in 1979, a mathematician named John Conway noticed something that should have been impossible. He found a numerical connection between the monster group and a completely unrelated area of mathematics called modular functions, objects from complex analysis that have nothing, visibly, to do with finite symmetry. The numbers match too precisely to be coincidence. Conway called the connection moonshine because it seemed like something dreamed up under the influence. The conjecture was proven in 1992 by Richard Borchards, who won the Fields Medal for it. The proof required building a bridge through theoretical physics, specifically through string theory. The monster group, it turns out, describes the symmetry of a particular string theory model of spacetime, so a purely abstract mathematical object, discovered through pure logic, with no connection to the physical world, turns out to be encoded in the mathematics of the universe's fundamental structure. The anomaly is not that the monster exists. The anomaly is that it was waiting there, in the abstract machinery of symmetry, decades before physics needed it, as if the universe's deepest laws were written in advance, in a mathematical language we only stumbled onto by accident. Number 9. P versus NP, the million-dollar question about the limits of thought itself that no computer and no mathematician has been able to answer. There is a class of problems in mathematics that are easy to check but hard to solve. A jigsaw puzzle is the classic example. Given a completed puzzle, anyone can verify in seconds that it is correct. But starting from 1,000 scattered pieces, finding the solution could take days. The question is whether these two categories, easy to check and easy to solve, are actually the same category in disguise. That question is called P versus NP, and it is one of the 7 Millennium Prize problems, with a $1 million reward for whoever answers it. The consensus among mathematicians is that P does not equal NP, that some problems are genuinely harder to solve than to verify, but no one has proven it, and here is where the anomaly becomes disturbing. In 1993, a pair of researchers proved a result called the relativization barrier, which showed that the standard techniques of mathematical proof are incapable of resolving P versus NP. Then, in 1995, another result called the natural proofs barrier eliminated an entire second category of proof strategies. Then in 2008, a third barrier was identified. The problem has now been shown to be unreachable by every known method of mathematical reasoning. The implication is strange and unsettling. P versus NP might be true, or false, and perfectly provable, but provable only by a kind of mathematics that does not yet exist, and may not be discoverable by minds like ours. Or it might be one of those statements that Gödel warned us about, true, but unprovable forever, within any system we could ever build. If P does not equal NP, then there are truths in the universe that can be recognized instantly, but never found except by luck or exhaustive search. Reality itself may contain answers that exist, but cannot be reached. And the mathematics that should tell us whether this is the case is the one question mathematics cannot currently touch. Number 8. The Riemann hypothesis. A 165-year-old guess about prime numbers that controls the security of the entire modern world, and remains unproven. Prime numbers are the atoms of arithmetic. Every number is built from them, and they cannot be broken down further. In 1859, the German mathematician Bernhard Riemann published a single paper, only 8 pages long, in which he proposed a precise formula describing how the primes are distributed among all numbers. At the heart of the formula is an object called the zeta function, and Riemann's hypothesis is that all of its non-trivial zeros lie on a single straight line in the complex plane. That is it. One line, one guess. 165 years later, it is the most famous unsolved problem in mathematics. Computers have verified the hypothesis for over 12 trillion zeros. Every single one lies exactly on the line Riemann predicted. The evidence is so overwhelming that most mathematicians assume it is true. But assumption is not proof, and the anomaly is that proof has resisted every attempt, from every direction, by the greatest mathematical minds of the modern era, and the stakes are not academic. The encryption systems that protect every bank transaction, every military communication, every password on Earth are built on the difficulty of factoring large numbers into primes. The hidden order of the primes, the exact thing the Riemann hypothesis describes, is the foundation of global digital security. If the hypothesis is ever proven in a way that reveals a shortcut through prime structure, every encryption system on the planet could become vulnerable overnight. But the deepest anomaly is stranger than security. The zeros of the zeta function, it turns out, are distributed with exactly the same statistical pattern as the energy levels of heavy atomic nuclei, uranium, plutonium, the same spacing, the same correlations, a pattern from pure number theory appearing in the physics of the atomic nucleus. No one knows why. No one has ever come close to explaining why. The numbers that define arithmetic and the particles that define matter appear to be reading from the same hidden script. Number 7. Gabriel's horn. The shape with infinite surface area and finite volume, that you could fill with paint but never paint. Take the curve 1 over x, rotate it around an axis, and extend it to infinity. The resulting shape is called Gabriel's horn, or Torricelli's trumpet, and it possesses a property that should be logically impossible. Its volume is finite, exactly pi cubic units. Its surface area is infinite. This is not an approximation. It is an exact mathematical result, proven in the 17th century and verified by every rigorous method since. You could fill the entire horn with a finite amount of paint, but no amount of paint in the universe could coat its inner surface. The same paint that fits inside the horn cannot cover the walls that contain it. The mathematician Evangelista Torricelli, who discovered this in 1641, was reportedly so disturbed by his own result that he struggled to publish it. His contemporaries called it a paradox, a monster, an absurdity, but it is not a paradox. It is a theorem. It is true. The anomaly matters because Gabriel's horn is not an isolated freak. It is a window into a deeper strangeness. The fact that infinity, when it enters mathematics, does not behave like a large number. It behaves like a different kind of existence, where containment and covering are different things, where the inside of an object can be bounded while its skin is endless. Physics has quietly absorbed this anomaly. The mathematics of black hole entropy, of event horizons, of certain quantum field calculations all contain echoes of Torricelli's discovery, situations where finite regions possess infinite properties. The horn was a warning, delivered 4 centuries ago, that the relationship between space and the things that fill it is not what our intuition says it is. We just did not know yet what it was warning us about. Number 6. The Monty Hall problem. The puzzle so simple a child can understand it, and so wrong feeling that 10,000 PhDs wrote angry letters insisting the correct answer was impossible. In 1990, a reader submitted a question to Marilyn Vos Savant's column in Parade magazine. The question was based on a game show scenario. You are shown 3 doors. Behind one is a car. Behind the other 2 are goats. You pick a door. The host, who knows what is behind every door, opens one of the remaining doors to reveal a goat, then offers you the chance to switch to the last unopened door. Should you switch? Vos Savant answered yes. Switching doubles your chance of winning, from 1/3 to 2/3. The response was an explosion. Parade received over 10,000 letters, an estimated 1,000 of them from people with PhDs, many from professional mathematicians, all insisting that Vos Savant was wrong. The letters were not polite. They accused her of embarrassing herself, of spreading mathematical illiteracy, of being proof that women should not write about mathematics. Paul Erdos, one of the greatest mathematicians of the 20th century, refused to believe the answer until he was shown a computer simulation. Vos Savant was right. She had always been right. The answer is provable, demonstrable, and reproducible in any simulation you care to run, and it still feels wrong. Even today, after decades of explanation, a significant fraction of people who hear the problem for the first time reject the correct answer with absolute confidence. The anomaly here is not in the mathematics. It is in us. The Monty Hall problem is proof that human intuition about probability is not merely imperfect. It is systematically, reliably wrong in specific, predictable ways, even among the most mathematically trained minds on Earth. If our instincts about something this simple can fail this completely, the question becomes what else we are wrong about. What other truths feel impossible not because they are, but because the machinery we use to evaluate them was never built to see them. Number 5. The number 6, 174. The hidden attractor inside the number system that pulls every 4-digit number toward itself like a black hole. In 1949, the Indian mathematician D.R. Kaparkar discovered something strange. Take any 4-digit number, as long as its digits are not all identical. Rearrange the digits to make the largest possible number and the smallest possible number. Subtract the small one from the large one. Take the result and repeat the process. No matter what number you start with, you will reach 6,174 within 7 steps. And once you reach it, you can never leave. The digits of 6,174, arranged as 7,641 minus 1,467, produce 6,174 again. It is a fixed point, a mathematical black hole. Every 4-digit number in existence falls into it. Try it. Pick any number. 3,524 gives 5,432 minus 2,345 equals 3,087, then 8,730 minus 0,378 equals 8,352, then 8,532 minus 2,358 equals 6,174. 3 steps from a random start into the attractor. The anomaly is that no one can explain why 6174 has this property. Kapprekar's constant is not the output of a theory. It is not the solution to an equation anyone was trying to solve. It was simply found, sitting inside the number system, like a stone of a strange shape lying in a field, obviously placed there by a process no one can describe. There are similar constants for 3-digit numbers and for longer digit lengths, each one an attractor with no known reason to exist. What disturbs mathematicians about Kapprekar's constant is not that it is unsolved. It is that it is unsolvable in principle. There is no deeper structure beneath it to discover, no theory it fits into. It is a brute fact of arithmetic. The number system, which we invented, which we built from the simplest possible rules, contains objects that behave like intentional designs. Whether that says something about the numbers or something about the minds that find meaning in them is a question mathematics has never been able to answer. Number 4. Graham's number. A number so large that the universe is too small to write it down, and if you could hold it in your head would collapse into a black hole. In the 1970s, the mathematician Ronald Graham was working on a problem in an area called Ramsey theory, the study of how much order must exist inside sufficiently large structures. To state an upper bound for his problem, he needed a number. The number he derived is called Graham's number, and for years it held the Guinness World Record as the largest number ever used in a serious mathematical proof. How large is it? It cannot be written in ordinary notation. It cannot be written in exponential notation. A tower of powers reaching to the moon would not begin to describe it. It requires a special system called Knuth's up-arrow notation, and even in that system, the definition must be built in 64 recursive layers, each one incomprehensibly larger than the last. The observable universe does not contain enough particles to write the number down, 1 digit per particle. It does not contain enough particles to write down the number of digits, or the number of digits of the number of digits. This nesting failure continues further than language can follow. And here is the anomaly that physicists added later. Information has a physical cost. Storing digits requires matter and energy. If you attempted to encode Graham's number inside a human brain, densely, using every particle of mass available, the information density would exceed the Bekenstein bound, the physical limit on how much information can exist in a given region of space. Your head would exceed the density required for gravitational collapse. It would become a black hole. So Graham's number is not merely large, it is physically unthinkable, a number that cannot be fully contained in any mind made of ordinary matter anywhere in the universe. And yet it is finite, it has a last digit. Mathematicians know what that last digit is. It is 7. A number too vast for reality to hold ends, quietly, in a 7i, and was born from a problem about nothing more exotic than coloring the edges of cubes. Number 3. The busy beaver. A simple question about simple machines whose answer is not just unknown, but unknowable, forever, by any intelligence that could ever exist. In 1962, the mathematician Tibor Rado defined a strange game. Imagine the simplest possible computer, a Turing machine, a device that reads and writes symbols on a tape according to a fixed table of rules. Now ask, among all such machines with, say, 5 rules, which one runs the longest before halting? The number of steps that champion machine takes is called the 5th busy beaver number. The first busy beaver numbers are tiny. The first is 1, the second is 6, the third is 21, the fourth is 107. These were computed by hand. The 5th was only settled in 2024, after a decades-long collaborative effort, and the answer is 47,176,870. The 6th busy beaver number is already known to be larger than a number so big it towers past anything physical. And here is the anomaly. It has been proven that no algorithm, no computer, no formal mathematical system can ever compute the busy beaver numbers in general. The sequence is provably uncomputable. It grows faster than any function that any possible mathematics can name. Not faster than any function we have named, faster than any function that can be named by anyone, ever, in any consistent system. This is not a limitation of current technology, it is a theorem. The busy beaver numbers encode, directly, the limits of provability itself. Computing far enough into the sequence would settle every open question in mathematics, including the Riemann hypothesis, including Goldbach's conjecture, including everything. The sequence contains all mathematical truth, compressed into a row of numbers that no conceivable intelligence could ever fully read. It is the closest thing mathematics has to an absolute wall, a boundary past which knowledge does not merely become difficult, but ceases to be possible in principle. And it was built from a machine so simple that a child could operate it with pencil and paper. Number 2. Chaitin's omega, the number that contains the answer to every mathematical question and can never be computed, even in theory, even by God. In the 1970s, the mathematician Gregory Chaitin was working at the intersection of computation and information theory when he defined a number unlike anything mathematics had seen. He called it omega. It is defined simply: pick a programming language, and omega is the probability that a randomly generated program in that language will eventually halt. A probability, a number between 0 and 1. Harmless sounding. But omega's digits hide an abyss. Chaitin proved that omega is irreducible. Its digits are not just patternless, like pi's appear to be, they are provably, maximally random. Each successive digit of omega is a mathematical fact that cannot be derived from any simpler fact. To know the first 1,000 digits of omega, you would need 1,000 independent, unprovable truths added to mathematics as raw assumptions. To know all of them, you would need an infinity of axioms. The number cannot be compressed, cannot be computed, cannot be approached by any method that exists or could exist, and every digit answers real questions. Whether specific programs halt, and encoded within that, whether specific mathematical conjectures are true, is written into omega's bits. The truth about the Riemann hypothesis is in there. The truth about P versus NP is in there. Every yes or no question mathematics can ask has its answer embedded in this one number. Omega is, in a precise technical sense, the sum of all mathematical knowledge, and it is unreachable, not practically unreachable, like the far side of the universe, formally unreachable, like a proof of a contradiction. The complete body of mathematical truth exists as a single, well-defined, finite number, and is separated from us by a barrier that no intelligence, human or artificial, now or at the end of time, could ever cross. Mathematics contains a book of all answers, and has proven that the book can never be opened. Number 1. The number 137. The unexplained constant at the heart of physics that Richard Feynman said every good physicist should worry about, and that no theory has ever derived. In physics, there is a number that appears everywhere and is explained nowhere. It is called the fine structure constant, and its value is approximately 1 over 137. More precisely, 1 over 137.036. It is a pure number, no units, no dimensions, no dependence on any system of measurement. It is the same for us, for any alien civilization, for any intelligence anywhere in the universe, and it controls almost everything. The fine structure constant sets the strength of the electromagnetic force. It determines how strongly light interacts with matter. It governs the size of atoms, the wavelengths of every color you have ever seen, the chemistry of every molecule in your body. If its value were a few percent larger, atoms could not hold electrons properly, and chemistry as we know it would not exist. A few percent smaller, and nuclear fusion in stars would stall, and the universe would be cold and dark and lifeless. And here is the anomaly. Every other quantity in physics is either measured directly or derived from theory. The fine structure constant is only measured. No theory, not quantum electrodynamics, not the Standard Model, not string theory, has ever produced its value from first principles. It is simply inserted into the equations, by hand, exactly as measured, with no explanation of why it is what it is. Richard Feynman called it one of the greatest damn mysteries of physics, a magic number that comes to us with no understanding by man. He wrote that every theoretical physicist should have 137 taped to the wall of their study as a reminder of how much we do not know. Physicists have tested whether it changes over time, over cosmic distance, over the history of the universe. Some measurements have hinted at tiny variations. None have been confirmed. As far as the best instruments in human history can tell, 137.036 has been the same since the beginning, everywhere, without reason. It is a number with no cause, no derivation, and no explanation, sitting at the foundation of every atom, every star, every chemical bond, the single most important number in physical reality, and the one whose origin physics cannot even begin to guess. It is not a solution. It is not a prediction. It is an instruction the universe follows, printed in the fabric of everything, in a language no one has ever learned to read. If you want to see more videos like this, subscribe, like the video, and share with a loyal friend.